Hey there, everybody. Dr. P back again with some more stuff from statistics, chapters 5 and 6 in your quant reasoning book. Deal with statistics, and so we are jumping back now to section 5.3. Those of you that are in my class, we've been doing chapter 6, and we're coming back to pick up some visual representations of data. And so that's really what this section is. I don't know that that's the title, but so we're doing some visual representations, and we've talked a little bit about some of these before, and I'm sure you're familiar with some of them before, but I'm just going to kind of take them through one at a time and make sure you understand the differences and the nuances of what's going on. Okay, so once again, I'm going to walk you through some stuff from your text. All right, and so we're in section 3, statistical tables and graphs is what they're calling it, again, visual representations. And so frequency table is something that we've talked about already. We have found means and medians for data given to us in frequency tables, but we haven't had to construct our own yet, and so we'll do that in this section. Okay, so the first column lists all the categories of data, and the second column lists the frequency of each category. All right, and you can use frequency tables specifically when you have lots and lots of different data points, but they're kind of grouped together. There's an easy way to group them together. That's the idea of the category, is grouping them together. Okay, and so I'm going to go here to this picture to kind of give you, and I'll go back and forth, how this looks. Right, so you've got your first column. This is the category, okay, or we call these classes sometimes. Okay, so these are the classes, and you'll notice that the classes have a couple of things in common. All right, so for the classes, there's two things you got to have. One is we typically have 5 to 7 classes. We don't want too little and we don't want too many. And then the other one is they are all the same size, right? So you can't have one class that goes 90 to 100 and another class that goes 80 to 89, because 90 to 100 is 11 different numbers and 80 to 89 is only 10 different numbers. So here you'll notice that 95, 96, 97, 98, 99, there's 5 numbers here. 90, 91, 92, 93, 94, there's 5 numbers here. Each class has exactly 5 numbers in it, and that's okay. That works, and there are 6 total classes, so that works too. So that's a great setup, okay? And so they've taken these 20 scores on a 100-point exam, and they've listed them all out here, and then they've just gone through and said, okay, how many scores are 90 to 95? Looks like there's only one score that's in that range. 90 to 92, all right? There's 2 scores there, and so we're just kind of confirming that and going through this process. But that's not really the process that they use typically to kind of determine these frequencies. This is already a summary, all right, of their frequency. This is a summary, but they have to actually count them up, all right? And so I'll show you how that's going to work here in just a minute. So there's 2 other parts to your frequency table. The relative frequency and the cumulative frequency. You got to make sure you read the problems, because often they don't ask you for both. They ask you for one or the other, but they don't ask you for both. Okay, so if we go back a couple pages here, what is the relative frequency? The formula for the relative frequency is the frequency in each category, or the particular category that you're in, or the class that you're in, the frequency in your class, divided by the total frequency, or the total number of objects, in other words, n, right? This is the number of data points, just like it always has been. All right, so you divide by the number of things, and then we want to write it as a percentage, so we multiply by 100%. That's relative frequency. In other words, if there are 5 people that scored a 95 or higher on the test, is that good or bad? Well, it depends. Is that 5 out of 20 or is it 5 out of 1,000? Right? That's why the relative frequency is such an important concept. And then the cumulative frequency here is just keeping track to make sure that all of your data values add up, right? So if we go down here, the relative frequency, you can see right? There are 20 scores. And so when I want to find the relative frequency, I take the frequency and I divide by the total number. 1 out of 20 is 0.05, which is 5%. 2 out of 20 is 0.10, which is 10%. 3 out of 20, 3 out of 20. Okay, so does this make sense now? That's how you do the relative frequency, okay? Cumulative frequency, this is just a count. In other words, I'm counting how many I've done so far. So I did 1, there's 1 of them so far. I did 2 more. Well, what is that? That's 1 plus 2 gives me 3. So that's my cumulative frequency. So far, I've counted 3 of them. I counted 1 of them in this column and 2 of them in this column, in this row, excuse me. This class has 2, and so 1 plus 2 is 3. Here, the 3 comes down, and I add however many are in my column, my row. This time I get 3 more, which is 6. Then I get 6 plus 3 more is 9, and then 9 plus 7 more is 16. And then, of course, the last number, better total how many you actually have, right? Or else you didn't accumulate everybody and you missed someone. So that's kind of a nice way to check to make sure we didn't miss anybody. Okay, this is kind of a nice check to make sure we didn't miss anybody. Okay? So that's how we create a frequency distribution. All right? So if you will go to oops, sorry, I'm in the wrong spot. If you will go to your worksheets, okay, which you can download from D2L, go to your worksheets, problem number 1, you'll see this problem. A manager at Sobeys is interested in the distance that the employees travel to work each day. So they're in kilometers, I guess. Sobeys is in Canada, and so they're using kilometers. And so the store is from his or her home and got these answers. So this person lives 1 kilometer, this person lives 18 kilometers, da-da-da-da-da. All right, so how do I set this up? All right, I will tell you how many classes to use. I don't want you to have to try to figure that out. I will tell you how many classes to use. So how many classes are we using here? We got 6 classes. Okay, which is great. 6 classes is fine. Okay, between 5 and 7. And notice that what's the smallest number? What's the range here? Well, the highest number is 18, and the lowest number is 1, and so we get 18 minus 1, and that range is 17. So how many data points are? So how many total? Not how many data points are there? There are 50 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 5. All right, and so there are 50 numbers total. But how many different data points are there? The range is 17, but that means 17 plus 1. That means there are actually 18 different values. Now, why did I add that? Because when you subtract 18 minus 1, that tells you the range between the top and the bottom number, but that's taking away 1, which means it doesn't actually include the 1. So if you start counting with the number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many numbers did I count? I counted 18 different values. So if I have 6 classes and 18 different values that are possible, that doesn't mean each of these values pops up. It doesn't mean that I get an 8. It doesn't mean that I get a 12, right? It means that there are 18 different possible values. And so, and maybe I should even put that, right? Different possible values. All right, then 18 values divided by 6 classes means 3 values per class. Because remember, they have to be the same size. So here's 3 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each class has 3 values. Okay, so that's why it's important when you pick your classes, you have to make sure that they come out evenly. All right, now again, we're just doing the very basics here. Sometimes it's not possible for your data to come out evenly, and there are ways that you can balance your classes, but for right now, just trust me that I will always give you stuff that comes out nice. All right, so here's the count. Here's how I suggest doing it. You guys can do it however you want, but I'm actually going to illustrate this. It's not going to be very exciting to watch, but I'm going to show you how I would do this because you want to make sure you get everybody. So I'm going to go through, and I'm going to count all the numbers in this frequency 1 through 3. So I'm going to count all the 1 through 3s. 1, 2, 3. So there's 1, 2, 3 in the first row. I'm using tally marks. How many 1 through 3s? There's 3. There's 1, 2 more. So if you guys are used to ever seen tally marks before, we do groups of 5. So 1, 2, 3, 4, and then a slash through the middle. That's a group of 5. Makes it easier to count when there's a large number of them. I'm looking for numbers 1 through 3. Here's one more. Numbers 1 through 3. Here's a 1. Here's a 2. There's 2 more. And then the last row, I get a 3 and a 2. So my frequency then is a total of 10 numbers in that range 1 through 3. Okay? I'm going to do it the same way for all of these guys. All right? So here's what I'd like you to do. I'd like you to pause the video, and I want you to finish this out. I want you to do 4 through 6, 7 through 8, 9, 10 through 12, 13 to 15, and 16 to 18. Pause the video, and then when you're done, run it back and we'll check your answer, okay? Well, I tell you what, let me do this too before we do that. So how do we do relative frequency? Well, how many numbers are there? There's 50 total numbers. So how do we do relative frequency? We take 10 over 50, right? 10 divided by 50 is 0.2. And then if we multiply that by 100%, we get 20%. Okay? So here's what I want you to do. I want you to do the frequency and the relative frequency for the rest of these 5 other classes. Okay? So go through and count. Here's a 6, here's a 6, here's a 5, there's 3 of those, da-da-da-da. Just go through and do the practice. Actually physically do it on your paper, all right, just because you need the practice to do it. Go ahead and pause the video now, and then when you unpause it, I'll take you to the answers. Okay, so you guys take as long as you need, pause the video, and I'll be back with you as soon as you start me back up. Okay, so you can see here that we've counted these up. There are 14 numbers between 4 through 6 inclusive, 10 numbers 7 to 9, 6, 10 to 12, 5, 13 to 15, and another 5, 16 to 18. We don't have a cumulative frequency column this time, so you might want to just add these up in your head real quick or with your calculator. 10 plus 14 plus 10 plus 6 plus 5 plus 5. That does come out to 50, so you didn't miss anybody. You didn't count anybody twice. And then the relative frequencies, 10 out of 50 is 20%, 14 out of 50 is 28%, 10 out of 50 is 20% again. All right, not a very good zero here. 6 out of 50 is 12%, 5 out of 50 is 10%, and 5 out of 50 again is 10%. And that adds up to 100%. If you round off, you might not come out to a perfect 100%, but in general you should. Okay? So that's the process of how you handle a frequency distribution. Okay, and how you create a frequency distribution with relative frequency, in this case, out of a just a set of data. All right, so now let's go back to the notes and talk about the other things that we have in this setup with regards to data. All right, so there are pie graphs and bar charts, bar graphs and pie graphs, okay? And each of these have a category and then a frequency of the grade. And so here we have the frequency and here we have the relative frequency on the other side. That's not always going to happen, okay? But often it does. And then here we have the same data shown in a pie chart. All right, now pie charts have to be labeled out this way. I am only going to ask you to read these, not create them. Okay, so you do not have to create a bar chart or a pie graph. You do not have to do that. Okay. However, there is a type of graph that I am going to ask you to create, and that's called a histogram. Okay, so The histogram, I'm not going to worry about the line chart that goes with histograms, so you do not worry about line charts at all, and we're not even going to talk about time series. They're pretty cool, but for sake of time, we're just going to focus on the histogram portion of the program. It's a bar graph, but the bar graph is not specifically enough. The bars touch one another to represent that there's no gaps in the data. Okay, so notice up here, these bars are long and thin. For a histogram, the bars are going to be fat and touching each other. Okay, so here's an example of a histogram. See how they touch each other? And so what does this mean? This is the number of people that got from 70 to 74. This is the number of people that got from 75 to 79. And I'm going to want you to label the classes better than this. I'm going to want you to say 70 to 74, not just 70, right? And then this class is 75 to 79, etc. Okay, these are the same. These are the numbers that came from the first example. Again, I don't care about the line charts, okay? Because what happens is they just put a dot in the center of each of these and connect the dots. And so I'm not going to worry about that. All right, if you can do a histogram, you can do a line chart, but we're going to just focus on the histograms, okay? So here's an example. Let's create a histogram, and so that I have enough room and a better pen area here, I'm going to cut this out, and we're going to snip this and move it over onto our whiteboard. Okay, so nice and huge. I'm going to shrink this down a little bit. That's probably big enough, I think. All right. So now we're going to create on here. We're going to create, they've already done the frequency distribution. Okay, great. So, and they've already got these are the classes right here. These are our classes. So I'm just going to show you how to set up a histogram. Okay, so down this side, this is the number. Hashtag means number. Number of actresses that I can't spell. Not actresses, like mattresses, but actresses. All right, number of actresses. And on this side, right, we've got the ages. So the classes always go on the horizontal. Okay, so we can't start, we usually start at 0, but 0, we got our youngest actress is 20, so we're going to go 20 to 29. Okay. And then here, we're going to go 30 to 39. And here, we're going to go 40 to 49. And here, we're going to go 50 to 59. Here, we're going to start at 60 to 69. Here, 70 to 79. And here, 80 to 89. I need a little bit more room. This one was longer than I planned. Okay, very good. And so bring that out here. All right, and then of course that will end here. So my first bar will be up like this, my second bar, my third bar like that. Okay, so now 34 is the largest number. I don't want 34 ticks. All right, so maybe what I'll do is I'll count by 4. All right, so this will be my number 4. That's too low. All right, and if you counted by 1 or 2, that'd be fine. I just run out of room here, probably. Well, let's try to do 2s, in that way that's not too bad. So I need 17 bars. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. 24. All right, so here's the fun of this. Make this even smaller. Oops. Undo that. Oh, that's what I need to do. I just need to take all these guys and move everybody down. Didn't quite get everybody, did I? All right. That's pretty funny. All right, and then we'll take this one and move down as well. All right, that's pretty entertaining. Sorry about that, guys. That's kind of a mess, and I've got a couple little pieces that I got to clean up here, and that's all right. All right, so some of the fun of technology, I'm still learning it, right? So make this go all the way down through here, and I got to start counting again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. All right, so this is 34 up top. This is 2, 4, 6, 8. Hopefully you guys would label them perfectly, but I'm running out of stuff here, so I'm not going to bother to do that. So 32 actresses for 20. So I go all the way up to 32, draw over. I would draw these a little bit straighter lines, a little bit better, because I have this stupid pad. It's a little bit hard to do. I'd use a ruler probably to a straight edge of some sort. I'm not going to grade you on how straight your lines are, but trying to get them straight is nice. All right, so there's 34. Okay, 14, 2, 4, 6, 8, 10, 12, 14 is right here where actresses is. There's 14 right there. So that's where my level comes up to for 40 to 49. There's only 2 actresses, 50 to 59. That's way down here. There's only 6, 60 to 69. So that comes up to here. And then there's only 1, 70 to 79. And only 1, 80 to 89. Okay, and again, I'm limited with the quality of the drawing I can make here because of the paper, the tablet that I have. But you get the basic idea. Okay, and so this is a histogram. This is how we create a histogram. And so you've got basically 2 parts to doing this. One is making the table, and you have to be able to do that. And the second is being able to do the histogram. So really, when you think about it, there are 4 things that you have to do with histograms and frequency tables. Okay, there are 4 things to do here. One is to be able to read a frequency table. The second thing is to make a histogram. Sorry, read a histogram. Know what it says, know what it means. All right, and then the third thing is to make a frequency distribution, a frequency table from data. And then the fourth thing you got to do is make a histogram from a frequency distribution, a frequency table. All right, so what I won't do is I won't give you a problem that's 2 parts. I won't give you a problem that says create this and this from the same data, because then if you goof this up, then your histogram's not going to be right, and it just can mess everything up, right? All right, so there's really 4 things you have to be able to do when it comes to frequency tables and histograms, and you got to be able to read them and tell what they mean, and then you got to be able to make one from either from the data or from a frequency table. Okay, and then obviously there's a 5th one, which is answer questions from a frequency table or a histogram, but also or a bar chart, right? Or a bar chart or a pie graph. So you have to be able to read all of these guys, but you only have to be able to create these 2. Okay? So that's the plan. If you go down and take a look at the rest of your handouts, All right, you'll see there's another problem here. Problem 2 here. Let me help you out with this just a little bit. All right, what's the range of problem number 2? All right, well, the smallest number in this whole data set looks like 89. Okay, that's the smallest number in the whole data set. The largest number in the whole data set is, I think, 137. Okay, so if you take 137, all right, just double check and make sure that I got those right, 89. If you do the subtraction here, you will get a 8 and 4, 48, which means that the number of values, right, the number of possible values is 48 plus 1, which is 49. So I'm going to say use 7 classes because 7 goes evenly into 49. So the very first number you should start with here is 89. That's your first class, 1, 2, 3, 4, 5, 6, 7. And then your very last class should end with 137. There should be no leftovers because these numbers come out perfectly, right? But remember, how big does your class have to be if you have 49 data values and 7 classes? Okay, well, you divide, which means you need 7 classes. Well, if you need, 7 points. So 7 points, 89 plus 7, right? Be careful, 89 plus 7 is 96. But that's not right, because if I start listing the numbers between including 89, because remember subtraction and addition doesn't really start with 89, it goes to the next number. How many numbers do I have here? 1, 2, 3, 4, 5, 6, 7, 8. That's too many. I only want 7 numbers in my classes, right? Because 7 goes into 49 7 times. And so your first class should be 89 to 95. There are 7 numbers there, even though the distance between those two numbers is 6. But there are 7 numbers if you count them. Here they are, 1, 2, 3, 4, 5, 6, 7. All right, so when you're doing your IQ classes here, make sure that you group them in groups of 7 and there's no gaps. So the next number would start with 96 and go on. Okay, so that's that problem. The rest of these problems are giving you charts. Here's a bar chart. There's the answer. Here's a pie chart. There's the answer. Okay, for this here, in this example 3, 1, 2, okay, these are actual numbers. These are actual numbers. So to find percentages, you have to add them all together to get the total, to get the percentage, the relative frequency. All right. Here, these are given as percentages. Skip that percent increase and decrease. We did that a long time ago. All right, same thing here. These are not percentages. Wait a minute. Yeah, these are not labeled as percentages, right? Oops, wrong way. These are not labeled as percentages. These are numbers. So to find the percentages, you got to add them up and divide. Okay? If they were percentages, they'd have to add up to 100, and they clearly do not. So go through these. The answers are at the end. Okay? And so if you go through that stuff, you'll be fine. And then, of course, as always, there'll be a My Math Lab available for you afterwards. Okay? So we went through, here's your picture, there's your frequency distribution. This matches what we did here. Not as pretty as theirs, but I don't care. This is not an art class. Okay? So, as always, shoot me an email or text me if you got questions, and hopefully that will help you with section 5.3. This is to be watched and done by Tuesday, by our next class. Please watch this and try some of the My Math Lab problems at least. Work through your worksheets and come with questions, and we'll take those on Tuesday. Okay, guys? Thanks. Stay safe. Talk to you soon.